Welcome to the Real Python Podcast. This is episode 24. Have you wondered, how should I package my Python code? You've written the application, but now you need to distribute it to the machines it's intended to run on. It depends on what the code is, the libraries it depends on, and with whom do you want to share it. This week on the show, we have Itamar Turner-Trauring, creator of the website pythonspeed.com. We discuss his article, Options for Packaging Your Python Code, Wheels, Conda, Docker, and more, which covers that other vital question of how to share your code. Itamar also briefly discusses his Python memory profiler named Phil. We talk about his recent PyCon 2020 presentation, small big data, what to do when your data doesn't fit in memory. We also cover several other resources available on his website for data scientists that want to get deeper into Docker. So let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Itamar, welcome to the podcast.
Hi, thanks for having me.
So I was wanting to start off talking about your website in general and talk about the name Python Speed and maybe your thoughts about why you came up with that.
So naming websites is hard. So
yeah,
partly it's like, what can I find? And I have another site, codewithoutrules.com, which focuses on sort of more generic sort of programmer productivity content. And I wanted someplace to talk very much about like Python related technologies and tools. And so one of the things that Python gives you is sort of, it lets you develop software quickly. It's also sort of inherently a slow language. And so there's just a lot of work you have to do to make things go faster. And so there's all these libraries built up upon it. And so that's one part of it, is just sort of, making people more productive, both in terms of like the way they write software, but also just in terms of computer efficiency. Sort of a long-term personal goal of mine is sort of to do stuff related to climate change. Computing is a big resource in terms of like carbon emissions.
Yeah, definitely.
And so like more efficient software is good, but also one of the things that excites me about the Python these days is that it's being used by a lot of scientists, people outside the sort of like web development world. Like there's a whole bunch of science and sort of non-software engineering that's happening with Python. It's sort of helping people who are doing research, scientific research with Python is also a thing that I'm excited about. And because it's a good thing in general, it also like there's a lot of people who are doing stuff related to climate science and energy efficiency and so on.
Yeah. What are you doing day to day? Like what's your regular gig outside of creating articles on your website and such?
So I do some training. So I've had some already classes I'm teaching on Docker packaging for Python. So intro to Docker packaging, production ready. Just a lot of details to get there. I've created some related products that I sell, and I also do some amount of sort of software development and consulting in addition.
Cool. You were recently on Michael Kennedy's podcast, Talk Python to Me, talking about your new, one of your latest software development projects of Phil, your memory profiler.
Yeah, basically, I at one point had a job where I was doing sort of algorithm pipeline for processing images for gene sequencing at a startup around here. And memory usage was a sort of massive bottleneck, not just in terms of hardware, like costs, like, you're running stuff in the cloud and RAM is really expensive.
And images are huge.
Yeah, this was like spatial gene sequencing, so it was a lot of data. But more broadly, memory is a lot more of a bottleneck in software processing data than you think. It's more expensive. You tend to be running much closer to capacity. When things go wrong, it's not like, oh, my program is slow. It's my program crashed and I have no results, or my computer is utterly wedged.
Right.
And so I've been writing a lot about how to sort of reduce memory usage, but like in order to reduce it, you need to measure it. And the tools that existed for Python were not really sufficient for that because they're much more focused on memory leaks. If you're doing data processing, like you load in some data and process it and exit, the main issue isn't memory leaks. The main issue is just you loaded a lot of data, your memory usage spiked. And so that spike, that peak moment, the high watermark is what you need to find. The existing tools didn't do that.
Okay.
So I wrote a memory profiler to sort of capture that. The initial version would run on a full program. Like so you run it end to end, your whole process. This week I've been working on adding Jupyter support. So I just had yesterday I got it to work for the first time. So like just in your Jupyter notebook, you're writing some code and you say, oh, how much memory is it's going to use? And you can sort of use a Jupyter magic to profile just that function. And within your notebook, you get like a profiling report saying this line of code called by this line of code was responsible for 50% of the memory.
Wow, cool.
At peak. So hoping to release that sometime soon once I document it and clean it up.
Yeah. I was thinking you probably recorded that podcast a month or 2 months ago, right?
Yeah, it was about a month ago, probably.
Okay. So you've been working on it quite a bit. That sounds cool. Like I know that's a really common environment to be working inside of notebooks as far as developing huge amounts of the data science community. They feel comfortable in it because it's, very, I don't know, interactive in a lot of ways. So that sounds like your tool will add to that interactivity and look at these huge data sets that people are looking at and where they could make things be more efficient.
Yeah.
That kind of leads to a little bit about talking your PyCon 2020 talk, which was a little bit about, kind of how to reduce the footprint of your project somewhat in memory. And I had a guest recently on, Hannah, talking about her book, Thinking in Pandas. And that led into a lot of some of the similar areas where you guys are talking about efficiency and how to kind of make things run a little bit better, which your site dives really deep into. Your PyCon 2020 talk, tell me a little bit about that.
And so I guess the thing I'm trying to do in sort of the articles I'm writing and talks I give and training is like software is a sort of immensely useful tool, but there's a lot of I'm not even sure rough edges quite explain it. Like there's just the infrastructure underneath the sort of nice high level bits that we like to think about. At some point you have to hit this point where you like understand how the operating system is doing things or how the hardware works, or like unfortunately you can't just say this is the idea I'm trying to express, just do it. You have to have at some point you have to go lower down and hit that lower level detail. And so that's always I'm trying to teach is like, here's how to solve the problem, and here's just enough so you have a better mental model of what's underneath so that next time you encounter it, so you know how to approach it. And for reducing your memory usage, or to put it from the other direction, in order to process large amounts of data in limited memory, there's a bunch of fairly standard techniques that if you're a programmer, you probably actually, even if you can't quite articulate them, like you've just encountered them enough that you sort of know how to think about it.
I think about databases in that way. Like if you have any kind of background in that, you would structurally want to make things be efficient and work cleaner.
Yeah.
But that a lot of people don't have that background, right?
So, yeah. It's like if you've worked with databases, like you just like you learn these concepts by osmosis. And so my goal was to say, here are these concepts which apply also for things like using pandas or NumPy. Here's a general concept and here are the techniques. And the basic idea is to reduce memory usage, putting aside techniques involved, like how you structure your code, like not keeping references around. 3 basic techniques are compression. Like you can represent the same information in memory with just getting rid of redundancy. You can do that a variety of ways, but like the sort of simplest is like both pandas and numpys have used different data sizes for representing numbers.
Yeah.
And so if you only are presenting numbers between 1 and 100, you don't need the default 64-bit integer. You can use an 8-bit integer, and you've cut your memory usage like divided by 8.
That's huge. Yeah, it's such a big difference.
Yeah, and it's like it could be like you add like 10 lines, like 10 characters, or to your code, and you just cut your memory usage immensely. So there's compression. There's batching, which is instead of loading all the data, you load it in chunks, process those chunks, and then maybe you're done, or maybe you combine the process data. By not loading everything, you can just process any data doesn't fit in memory. And the final one is indexing, where you'd have an index in a relational database where you say, I'm going to figure out a fast way to load only the data I need. And then I can only load the subset of data that actually matters. So like if you're doing looking at data on a month-by-month basis, if you have an easy way to load only July's data, then you've saved all the effort of filtering out August and June and May. And so those three techniques you can apply in Pandas and NumPy using built-in facilities they provide, or sometimes external libraries.
Yeah, it sounds like a lot of what you're doing is similar to some of the training that I would do. I've worked in training for musicians, and I did some retail training with Apple, and I've done training for phones and computers and sort of just general digital sort of stuff. And a lot of it is I call it sanding off the sharp edges. Making sure that people aren't hurting themselves as they're going through this process and making these painful mistakes again and again, and getting them to the point where they can use stuff. It sounds like that's a huge part of what you're trying to do in the data science world.
Yeah. And I mean, in an ideal world, people wouldn't have to think about this. And there are tools that are starting to work on that, but in the end, there's always some level of, if you're processing data, you pretty quickly become an expert on the structure of the data. Like, I know nothing about biology, but when I was doing the sort of algorithms for gene sequencing, I'm not even an expert at image processing algorithms. There were people who were much better at me who took up the work later, and I'm sure improved it vastly. But I ended up with a very good intuitive model of what the data was like and how it was structured, and how you might compress it, and which were very specific to the data, just because spending so much time staring at it and thinking about it.
Yeah, that's cool.
And so if you, in the end, because you're the expert in your own data, it's useful if you understand the techniques you can then apply to using your expertise.
One of the things I wanted to talk to you about, and I mentioned on last week's episode, was you had written an article called Options for Packaging Your Python Code, and Wheels, Conda, Docker, and more. I wanted to kind of take it to initially a little bit of a higher level and talk about the intent behind this article. There's sort of two sort of scenarios I can kind of think of that I could divide things in, just, I don't know, sort of initially. One would be, I think of it as the portability of software. So this would be more for internal kind of uses, for maybe you're a team of one, or you're on a small team and you're needing to have this code be portable, move to machine, or stand up another instance of something, what have you. And then there's another version of that, which would be, I would call it deployment of software, where you're really handing it off to somebody else entirely, and it's going maybe outside your organization, or it's getting out there to the wider world, like all the way to something like open source, or in some cases it could be a product or something like that. Is that intent in both sides of that? Is that intent in your article? Is it more toward one or the other?
I guess the original idea for writing this came from talking to someone who was thinking about sort of distribution within their organization. They were using one tool and it wasn't working quite well, and they were looking at another.
Okay.
But it got me, for any question about software, any question about what should we do in general, the answer is always, it depends.
Yeah.
It depends on the situation. And so, in my just writing software, using software, I just encounter, you encounter this very wide array of solutions. And if you are working on your own software and you encounter these, and it can be sort of overwhelming and confusing. Why do all these things exist? It may be that many of them are for each individual completely irrelevant, but it's good to know sort of the way people conceptualize things, what might motivate people to use these tools or create these tools.
Right.
And so the idea was sort of, here are all these options, they might seem very similar, what are the differences between them? And so once you have that sense, then when you hit a specific situation, you can say, oh, that's why that thing exists. So you sort of, by having sort of big picture, these are the the sort of extremes between include everything, include just your source code, and everything in between, you can sort of get a sense of why these exist and why you might choose them.
Okay, so the scenarios might be in either of those camps then, depending on the tool.
Yeah.
Okay, that makes sense. So one of the things I was talking about last week was an article on RealPython about wheels, which I had seen and had, kind of been around, and maybe I was downloading an open source project and that was what was available. And I was unaware of the relationship of, how pip uses them. And so we talked a lot about that last week. And that's kind of one of the first things you kind of start off with is talking about Python package installed with pip, like a wheel. And what are the scenarios there? Like what are some of the reasons that you would use that option?
So I guess the one very big dividing point is libraries versus applications.
Okay.
And so my article was focused on applications, which you can distribute with wheels. But one starting point is like if you're distributing a library, you want, like, especially if it's open source, you don't want it to be like on the PyPI, the Python warehouse, so people can just do pip install.
Yeah.
You might have libraries within your organization that different developers are using for different applications. So you might have a local server that serves things that pip can talk to a local server, or even like other things, like you can give it a URL.
Have you set up that kind of thing before?
Not sure I have. There's a dev PI is sort of a common server people use for internal deploys. If you can also just give pip I believe you just give it HTTPS URL or even a Git.
Okay. And you just sort of pointing it at that,
Yeah.
and it'll look at that repository, say, if you will, first, before it would go to the outer world, or you can say, just use this particular repository.
Yeah. And so you can do things like mirror PyPI. So like if PyPI is down, doesn't break your deploy, you can have your own packages added.
Yeah.
And so libraries, you want, you'll want the package in that way, probably. What wheels give you is, traditionally you would distribute just the source code. And for a pure Python library, maybe that's fine. But if you have to compile something, that means whenever you install a package, you have to compile it, which can sort of just require work in terms of you have to set up have a compiler and development headers, and it can be a pain. And if you're deploying to 100 machines, it's just a waste of resources to compile the same thing 100 times.
Right.
And so a wheel lets you.
So it makes sense to pre-do that. Also, in that case, what you would be compiling would be, something that's, you said, outside of Python, like a lot of stuff you're talking about with sort of speeding up code very often will be working with C libraries, right?
Yeah, like C or Python, or if you're a scientist, you might use Fortran or C++.
Okay. And so your tool would then be compiled, and that's kind of where wheels get interesting, because then you're needing to target, right, the environment and machine that you're going to put it toward.
Yeah, so you need a Linux wheel or a Mac OS wheel or a Windows wheel. And so it used to be when you'd install Python packages, it was just a lot more work because you had to compile everything. Whereas these days, much of the time, you don't have to use a compiler at all because the maintainers of the packages have created, if you install matplotlib or pandas or Postgres library, they've precompiled them for you. And so you don't have to have a compiler to use these libraries. You just install them.
Yeah, that's great.
So that's libraries. But you can also use wheels and then pip to distribute small applications. So a lot of Python development tools are distributed this way. So like Flake 8 or Pylint or Black,
yeah,
or pip itself, for that matter, are all these little tools you can distribute. You can do pip install. And so for development purposes, that's great, because if you're distributing it to a Python developer already have pip, just assume they'll have it. And so in some cases, that's fine. Beyond a certain point, you start hitting certain limitations of wheels. If they depend on other, wheels are fundamentally designed for libraries. So it's supposed to be one package. And so if you your package depends on a bunch of other packages, now you have to install all of those.
Right.
And so they might conflict with something else you have installed. And so there's a tool called pipx, pipx, that sort of wrap around pip that'll create a little virtual env for each of your different tools. And so you can install Flake 8 in one little virtual env and Black in a different virtual env, and it'll make sure you can still call each program, do it differently. You can include shared libraries and wheels. There's a bunch of extra work. There's like for Linux. There's like a mini Linux project that lets you sort of does the work to do that. For all of these tools, you can sort of push them beyond what they are originally designed for. Like if you, for example, are distributing a Windows GUI application that you expect non-programmers to use, in theory, you could distribute it with pip. In practice, like the user interface consequences would be so confusing to the end user that you just...
It'd be quite the to-do checklist to make sure they've got everything ready to go.
Yeah, it'd be like, download this, then open a terminal and type this, and then no one ever do it. And so you can shoehorn a lot into just the wheel, but beyond a certain point, maybe you don't want to.
Yeah. That move us into the next one of PEX and friends?
Yeah. So wheels, while in theory you could shove multiple libraries into a single wheel, occasionally people do that, like it's called vendoring. And so like, pretty sure if you look inside, it actually has a bunch of vendors libraries and I believe requests.
That one definitely does, yeah.
Yeah.
It grabs like 5 or 6 things.
Yeah, and so that's just to make it easier to install. But it's not like it's extra work, and it's not like the tooling isn't really designed for that. And so the next step is to say, I would like to distribute a thing that has all of the source code necessary to run my application and maybe even some C shared C extensions in one file. And there's a bunch of these tools. They build on ZipApp, which is sort of built into the Python standard library, but ZipApp doesn't do like C extensions, so it's a limited use.
Okay.
And these tools typically come out of large companies. It's like Google and Facebook and LinkedIn have all built their variants of this.
I found a Twitter lightning talk when I started researching it to talk about it in the last episode. And he had like a longer talk, but then this was like a 15-minute talk on the particular tool, PEX. And it kind of showed me, and it was, it was a while ago. It was probably, 7 years ago or something like that. Even at that point, it seemed like that was a useful tool as they were talking about sort of, again, passing code around utilities or whatever you want to call them, applications inside of an organization. So they would say, okay, well, this is where, the repository where you've put all these PEX kind of things.
Yeah. And so just to go through the progression, wheels typically include only the code for a library or application. It doesn't include the dependencies.
Okay.
PEX and the other things like that include both the application code and the dependencies, a sort of little instruction about what tool to run by default. And so it's closer to being a sort of executable than a wheel is. A wheel is like you install it and it drops some files everywhere. PEX file is a thing you can run.
Okay.
And so it acts a lot more like a command line tool. And so if you are distributing a little program, it's a sort of nice self-contained, just a single file you distribute. And it does not include Python. It's just the code so it presumes Python's pre-installed. And this is where the sort of internal distribution thing comes. Like if you're like in a large company, you can probably assume that like if you have a bunch of machines or virtual machines, they've all been like provisioned in the same way. Like you can assume like all the machines have Python.
And a particular version, like they would probably walk forward at a certain point.
Yeah. So you can assume there's Python, and like you probably have some way to distribute files to a whole bunch of machines. And so this is a way to distribute just the code. You don't have to like have an extra copy of Python. So you're not like if you have 10 scripts, 10 copies of Python.
Yeah.
So it saves some disk space.
Would you think of these as like command line types of things that would be run from a terminal or shell or?
Yeah, it's like, you can use it for like a server too.
Okay.
But it's sort of, there's this implied infrastructure. Like there's this presumption that you have servers and you're thinking about how much disk space and you have a way to distribute files. My impression is these tend to be used in sort of people that have like managed server farms.
Okay.
Virtual or otherwise. It's like as a sort of individual developer, like it's not clear to me where I would use it, for example.
Yeah, that makes sense. Does that take us up to the next level of the system packages?
Yeah. If you're doing a pipx, like it's typically like the Python code and maybe the Python extensions, but sometimes you need like system packages. Like you might need to have like some system package installed. And the PEX doesn't have any way to express the dependency. Like it doesn't have any way to say like you must have like libjpeg installed. And in theory, you can do a bunch of work to sort of shove it into the PEX, but more probably like if you're using a PEX, like you're in this environment where you can just assume that like you've pre-provisioned these servers.
Trying to think of those kind of tools. I'm into audio and video, so I can kind of think of like tools that on my Mac I've had to use Brew to install, probably to like add like MPEG compression or something for videos or photos or whatever, something in a scientific environment where they're needing to work with those types of compression and decompression or those kind of outside tools. I'm trying to think of other system sort of tools that would need to be distributed like that.
Yeah, I mean, sometimes it's libraries, sometimes command line tools. Okay, yeah, like video encoders. Like maybe you need some command line tool to talk to a server.
Okay.
With neither pip nor the PEX and friends, you don't have any way to express that dependency. Like you just sort of have to document you need it, or you need to find something to shoehorn into your package, which can sometimes be difficult or not worth the effort. And so another approach, and I think this is in many ways the oldest approach because this predates like the wheels, predates pip, predates PEX, is just system packages like Linux distributions these days. For example, Brew on Mac OS, the lesser, and I know there's some other systems because Choco from Windows. Like basically, you have the ability to say package some software out like an RPM or Debian package, and it can depend on other packages. And so this is sort of the traditional sysadmin approach to distributing software was you'd package up your Python code and its dependencies maybe as a virtual env or like in one place at least. And then you can install that as a regular RPM package, and you can have dependencies on other RPM packages. So you can say, I need the video encoder package, and then when you install it, like DNF or Yum will automatically install it. Or if you're in a Debian or Ubuntu, like apt will automatically know that it from the package that it has these dependencies. And so it lets you express dependencies on system packages that you require. And it still gives you that unit of installation of like you can install or uninstall your whole piece of software, upgrade it as a unit instead of just blocking files in the file system.
So sorry to take a step back, but what does RPM stand for?
I think it's a Red Hat package manager.
Okay.
That's a guess.
Versus the DEB, which is the Debian version.
Yeah, so DEB is the package format for Debian and Ubuntu.
Okay.
And RPM is the package format for CentOS, Red Hat Enterprise Linux, Fedora, all of which derive from what used to be Red Hat Linux.
Yeah. And then you mentioned apt there. It's like using like apt-get to add things to your Linux installation in kind of the same way.
Yeah, so in Debian and Ubuntu, you would install Debian packages with apt-get typically. And on Red Hat, like Fedora or CentOS or Red Hat Enterprise Linux, there's tools like DNF or Yum that install those packages.
Okay.
And so this is a traditional sort of system administration approach. Often the Linux distribution will package some Python packages for you already. Like there might be like a Red Hat matplotlib like package or Ubuntu matplotlib package. And you typically do not want to use those. You typically want to like package them yourself because like the release cycle of Linux distributions is...
Yeah, I can think of the date. Yeah, the versions would probably get pretty stale based upon the amount of time that somebody like a system admin would have to build those kind of resources.
Yeah, you don't the Debian stable will be like, or CentOS, like they spend years before they're updated, and so you don't want to be stuck with that particular version for years, or you don't want to be forced to upgrade when you want your Python dependencies to be in there on upgrade. But like things like a lot of the things that system packages provide are much more stable than like a Python library. It's fine to you want to depend on those and get that stability.
Feels like that might be almost split in the sense that you would have the environment that you're building, and then the Python stuff still might be separate in that case.
Yeah, exactly. And which is a good intro to Conda, the next one.
Okay.
And so we've been talking about this sort of divide between things you get from system packages, like a video encoder or something, or a particular library like libjpeg, and things that are like your Python code. And then Conda is a package system, and then there's a bunch of package channels, but conda-forge is the biggest and most popular. And Conda takes a different approach, and it says, we're not going to use system packages for basically anything.
Huh.
Like, we're going to package everything into one packaging system. And so you're going to have like your compiler and libjpeg and your video encoder and your Python packages are all going to be Conda packages. And we're going to package them separately from your Linux distribution or macOS or what have you. And it's all going to be in this one place. And conda-forge is the biggest place. And so you have, because you have just one package system that has all this stuff in it, you don't, like, it doesn't matter what Linux distribution you're on. So it's a bit like the experience with Brew, where you're not like, but if Brew also did Python packages, like it's like all in just one place. And it's also closer to being like a Linux distribution, that the people doing the packaging aren't always the authors of the software. So like if you're downloading matplotlib with pip, the people who package matplotlib are typically the people who wrote matplotlib.
They're part of that team typically then.
Yeah. And for conda-forge, like you can, like, I package other people's software for it. And so it's kind of like a Linux distribution or Brew in that sense. And so with Conda, you can have dependencies that are sort of which in the other approach, you think of as separate, like you don't think of your video encoder as a thing you install with pip. In Conda, you would install it with Conda, and you install the matplotlib with Conda, and they're both just Conda packages.
Wow. Okay. I'm not familiar with that part of Conda. I'd played with it a bit, and it always kind of became this kind of divide between, in the particular, I worked at a bank, and we would use an Anaconda initial distribution, and I'm familiar with the, adding Python packages through it, but I had never used it as a tool to add those other kinds of tools with it. So I guess that kind of leads to two questions. One is, are all of those things available from Conda directly? You can kind of search their directory and find those sort of resources. And then I guess the second one is, then how do you create the things? Are you using this Forge as a tool to build the distributions of C shared libraries and other things for yourself to be able to get to?
Yeah, so conda-forge is not a tool so much as a source of packages. So you can think of it as like just like a giant package repository. And so it heavy Python focus, but it also has other programming languages. And a lot of packages that are on PyPI that you can install with pip are also on conda-forge, but not all of them.
Yeah, that's where I kind of ran into where it would divide sometimes, where there would be occasionally things that were not available inside of it. They were really just pip specific.
Yeah. And so, like, if you go to the list of packages for conda-forge, it can include things like libjpeg, which you would never find in PyPI because it doesn't make sense for it to be there. Or libmemcached, just looking at the libraries now. libog, which is a audio encoding library.
Yeah, okay, for making OGG files, okay.
So it has these things. It also has a lot. So it has the most popular Python libraries typically. Because it's a sort of community project where you don't have to be the author to package stuff, they built this really nice infrastructure. So if for simple Python packages, and contributing to conda-forge is actually really easy. And there's like really nice automation. So wherever there's a new release, it sort of gives you pull request, and you look at it and you say, oh, that worked. You hit merge, and now you have a new version. So like adding stuff is pretty easy, but it's still like you have to do it. You can fall back to pip packages.
Okay.
And so when you getting back to distributing applications, you can, for an actual application, you might create an environment.yaml file, which is sort of a description of your dependencies. And you can also say, in addition to these conda packages, I want these pip packages too.
Yeah.
So for not for packages, you can't do that. But for your actual application, you do have the ability to fall back to pip if you have to. It's in many, like, especially if you're doing like data science or scientific computing, like there's a lot of packages focusing on that world that came out of You don't have to like fiddle around with system packages as a dependency because they've packaged many of the stuff you care about into conda-forge, and it gives you that sort of cross operating system packaging. Like instead of saying like, on Linux you install libjpeg this way, or rather on this Linux distribution, and you want to make sure you install libjpeg this way, and that Linux distribution you install libjpeg this way, and Mac OS you install this way. On Windows, I don't even know what you do on Windows.
That's what we were using in most of the bank was Windows installations of Anaconda and then using Conda from there.
Yeah. And
I could see that's why maybe sometimes it didn't have every single tool because maybe they weren't prepared, in that environment.
Yeah. The official Conda provided packages, I think, is a smaller subset. conda-forge is a much bigger, but also much more freewheeling and not, it's a community project, and that has some downsides sometimes. I imagine if I was a bank, I might be a little bit more wary.
Right, exactly.
And so that's sort of the next, like a different approach where you don't, like you just say, we don't want system packages. We want this to be sort of integrated, our Python and system packages to be integrated to one package system.
This week, I want to shine a spotlight on another Real Python video course. It covers the type of Python skills to practice so you'll stand out from the competition. It's titled Python Coding Interviews, Tips and Best Practices. The course is based on a Real Python article by James Timmons, and in the course, James Uegio takes you through how to use enumerate to iterate over both indices and values, how to debug problematic code with breakpoint, formatting strings with fstrings, sorting lists with custom arguments, using generators instead of list comprehensions to conserve memory, defining default values when you look up dictionary keys, how to count hashable objects with a collections.counter class, and how to use the standard library to get lists of permutations and combinations. I think it's a worthy investment of your time to learn the types of skills that will show your knowledge of Python. And like most of the video courses on Real Python, the course is broken into easily consumable sections, and you get code examples for the techniques shown. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com.
And so the next step is to say, like, I don't want my users to even think of this as Python program at all, or a thing like they have a packaging system. I just want to give them a program they run. And this might be where you're like distributing to people who aren't necessarily programmers, or it's just like, even if they are programmers, like this, they don't care what language it's written in. They just want an executable. And then there's tools that let you do that, and they will take all your Python code and your Python interpreter and create a single executable. PyInstaller is one of them. I think the most cross-platform one.
That's the one I used. I created some tools for some other users, and I talked about that a little bit, but it seemed like it kind of out of the box really just sort of worked for me. I didn't really spend a lot of time with it and didn't require a lot of additional tools. I definitely needed the environment to match between the two. I couldn't move to somebody else who didn't have a 64-bit machine. Like if I was compiling it on there or installing it on there, it needed to be, the same, distribution across both. I guess the biggest problem with it is that you are making kind of a large file in the sense that it has all of Python with it, right?
Yeah, it has all of Python. And also you end up with like this file and you have to distribute it somehow. It's like maybe then you want an installer.
Okay.
Like for do a Windows installer, or maybe you're an organization that has ways to distribute files. So it gives you this executable that can run, but then you have to, maybe you can distribute it to people, like they can download it, and then how do you update it? So it just solves the packaging Python and your code and dependencies into one file. It doesn't, if you're using Conda, you can use, if you do a Conda package, someone can install pip, someone can pip install. For exe, you're going to have to, like on Windows, you're going to have to like create it, wrap it with an installer and an update mechanism of some sort. Which you can do, but it's more work.
Yeah, it's harder to scale it out and have variations of things.
Yeah.
I had Russell Keith McGee on of Beware and Briefcase.
Yeah, which was another.
Yeah, really kind of a similar tool in that sense. One nice thing is it does add it adds the installer part, which is kind of nice. Like it'll create an actual MSI for Windows, and in the case of Mac, it'll have a DMG, where it literally shows like the picture of you dragging into the application folder, and
cool.
kind of handles some of that overhead. And then the one unique thing it adds is, of course, the idea of being on mobile devices, which is pretty cool, which they're still working on, and kind of geared toward GUI stuff in some ways, because he's developing these other beware tools of Toga, which is like this whole GUI environment, and trying to replicate all of that stuff. It's a really neat project. I had a little thing last week where I was talking about these things, talking about your article, but also talking about PyOxidizer as a project. And I got kind of stuck using it. It's a little harder in the sense that you do need to have an installation of Rust, and I had not used Rust at all. So I got Rust installed, and then I worked with the crates and things inside of Rust. But I only had a couple hours to kind of play in this environment, and I was able to make the example of creating a REPL, an executable REPL file, and working with that. But I once I tried to get beyond that and maybe include additional packages and so forth, that's where the documentation kind of started to break down. I was having to spend a lot more time on it. I didn't understand the BZL file very well. It didn't make as much sense. So you're laughing. Maybe you had a similar experience. I don't know.
I mean, if it's like, I'm hoping that's probably a Bazel file.
Yeah.
Yeah, I have. My encounters with Bazel have not been fun.
Yeah, it was weird. It just seemed like it's just where the documentation kind of fell apart. And I don't know. Have you used either of those in your own experience of actually trying to distribute things to other people?
I believe I may have used PyInstaller. I used to work on a project that was using PyInstaller in the past. I think PyOxidizer, like the reason it exists is because there's a bunch of optimizations for a much faster startup that it can do that PyInstaller can't.
Sure.
And so, but those optimizations basically just make it the way it works much more complex. Like it has to compile stuff.
Yeah.
Whereas PyInstaller is mostly just like smushing some files. The other PyOxidizer is much more sophisticated, but also more difficult. So yeah, I mean, PyInstaller, it just seems like it fairly straightforward. So like it seems like a good starting point.
Yeah, Briefcase, depending on what you need, was similar in that way. That was really like I was up and running pretty quickly. And again, I didn't need a mobile thing, but it was something I've been thinking about. I used to make tools for some small businesses where they wanted to go to be paperless. And so I was creating lots of little tools for them. Ended up using this thing called FileMaker because it was kind of a quick development platform where I could kind of get my ideas together and had a lot of the graphical elements and so forth. But now that I'm doing way more in Python and I want to be able to do maybe more processing and more crunching of things, and a lot of these packages I'm learning about, I'm looking at some of these other tools of PyInstaller and Briefcase maybe as a way of developing these things that I can give to a client where they're not going to want to open up Python and even be in a terminal, though depends on their employees and who they have on their team, as far as what you can distribute to them.
Yeah, I should add Briefcase to the webpage.
It's pretty neat. Yeah, I'm been impressed with it. Still not 1.0. We talked about that. Actually, I had a whole long discussion with Armin Ronecker about Flask and how he kind of stuck with the version for quite a while. It's sort of an intriguing area of development, whereas like where the creator finally feels like, yes, this is ready. I guess that kind of leads us to your next topic, which is a huge topic on your site in general, which is container images.
You can go a step further. Like if you're distributing like something packaged with PyInstaller or Briefcase, like it's an exe, but it's still presuming that like you have like certain shared libraries installed. And containers go a step further, and they basically say, we're going to package all the files you need to run an application into one thing.
Yeah.
One package. So maybe if you're writing a Python application, so it's a Python interpreter in your code and the dependencies and the libraries, but it's also the whole, like effectively a whole Linux distribution. And it might be just this very subset, the particular files in that Linux distribution that you need.
Yeah.
But it's like everything. And so like if you happen to need a very obscure particular shared library that has to be set up only in a particular way and only a particular Linux distribution, you can build an image that does that. Like it's just it's everything you need to run it. Like, it doesn't matter what the base operating system is, like it's going to, like that, you can run it. And so like you can package your Linux distribution plus Python plus code and then run on Mac OS or Windows using a virtual machine that can then run that container. And so, and then there will usually be some various levels of isolation because it's a sort of, think of it as like sort of a self-contained little thing. And so this goes to the extreme of you make no assumptions whatsoever about the external runtime environment other than being able to run a container image, which is true in a very broad, like,
Yep.
Which is there's a whole bunch of different ways to do that. So like you can run a Docker container in Windows, but you can also run it on various like specialized cloud services that Amazon provides, and the same image will run the same way with the same everything, all the same exact file system. So it's sort of the next step in terms of like a reproducible runtime environment.
Yeah, I've played with them and used 2 or 3 cloud services just kind of in my experiments and learning about them. You know, everything from Amazon to Heroku, which was actually a very pleasant experience using with setting up like a Django kind of thing. I haven't used them as much for data science, though. I did have Tanya Allard on episode 8, and she was talking about this topic quite a bit about containers and kind of goes through some parallel things that you've talked about on your site of creating images through stages and testing for security, and this whole idea in the world of data science, which is her focus also, of reproducibility. And in that case, you know, you are controlling through this container, if you will, you know, the operating system, the version of Python, you know, the file system, the database type, you know, all those kinds of things, along with all the other things you were talking about of your code. And so it's very reproducible. And so I thought that's kind of neat. But it's another layer of being a developer to understand Docker.
Yeah. So the thing about, Docker is sort of heavily, you can run, there's a Windows variant of Docker.
Right. Have you ever tried to make a Windows OS container, though?
I'm told it's difficult. I've never actually tried.
Yeah, it's not fun.
Yeah.
And they're huge too, right? I mean, that's the big problem with, you know, the whole idea with a container, hopefully, is to use something a bit smaller for the operating system and the file system, hence the popularity of Linux distributions.
Yeah. And so, you know, typically you'll be running Linux containers. And Linux is sort of based on Unix, which was created in I think first launched in beginning of the 1970s. And Docker builds on sort of Unix and features added by Linux. And then if you're using it for Python, there's Python packaging. And so basically, there's literally 50 years of technology decisions that all intersect in Docker packaging.
Yeah.
So, and I'm not exaggerating. Unix signals are sort of this. When you hit Control C and your program exits on Linux or macOS, so that's a macOS. It's kind of sort of a Unix signal, but on Linux, it's definitely a Unix signal. And that was a thing that was designed in the 70s, and it's problematic in a whole bunch of ways. And if you don't quite package your application correctly for Docker, when you hit Control C or otherwise try to shut down your container, that signal will get swallowed. And so it'll wait 10 seconds and say, oh, I guess clean shutdown failed. And then it'll kill it with extreme prejudice, the equivalent of doing kill -9. So you won't have clean shutdown, which maybe is fine. But at the very least, it means you hit Control C and then you sit there waiting. And it's annoying. And the reasons for this are design decisions that were made in the 70s and 80s and that still apply in Linux today. You know, that's just one detail, and just it all accumulates. And so do Docker package, depending on what you're working on, maybe you don't care. In many cases, if you're just running in your computer, you're just doing it for reproducibility, maybe you don't care about security. That's fine. If you're running in production, you kind of have to worry about it.
Yeah.
Maybe slow shutdown is a mere annoyance. Maybe slow shutdown is might have some impact on like your upgrade times and like on your service level agreement, like because your messes with your uptime. Like, but all of these, like literally, 40, 50 years of design decisions, some of which turned out to be mistakes. And like, these are smart people, but everyone makes mistakes. All of these details intersect in Docker packaging. And so like I have like, depending on like how important it is for you, like it might be quite important that it runs really well and securely and fast and small images. Like just, it's like my current list of best practices like 60 long, and I keep adding to it.
Oh, wow.
Because, and to be fair, a lot of people don't have to think of all these, but some people do. And it's just a lot of details to get right. And so on the one hand, it's this like really useful tool in many ways. On the other hand, it's just like, it can be a frustrating experience, and there's just a lot of stuff you have to get right.
Thinking about the 60 steps that you're talking about that are or not steps, but best practices, once you've gone through a lot of that, say for your own personal Docker container that you're going to say, this is the tool I'm going to use as a base to develop upon, how many of those 60 things will have been checked off in a sense so that you can move forward? I mean, obviously you're going to have to keep things up to date and pay attention to new developments, but is there a is there a flattening out of the learning curve at a certain point where you've developed a base container?
Yeah, definitely. Like and some of it you just start doing automatically, and some of it like you create one and like you copy paste some stuff. Like for the really sophisticated use cases I've created, I've made a template people can get. But for most people, like you do it once, and then like you have your own internal thing you copy, and that's fine. So it's not. It's not like you're committing to this like never-ending
New career path.
like, yeah. It's just you need to sort of you need to understand how it works, and depending on your what you're building, you might need to make sure you have this understanding like security, or maybe it'll turn out that it just takes a really long time to build the images, and so it's worth spending some time there and kind of speed it up. But once you're over the hump, if that weren't the case, I don't think people would be using it as much as they do. It's just this hump you have to get over. And so this is why I spend a lot of time writing about it, because it is such a useful tool.
Yeah.
It's just, it's not obvious. And
yeah. If you were, I haven't gone through all the resources on your site because it definitely has a huge amount of great resources for Docker. One question I have though is if you are, let's say you're way earlier on that curve and you haven't even set up Docker for the first time on, say, your own workstation, and you want to start investing time into this idea because you've seen other people using it and you think it'll be one of the best tools for what you want to do. Do you have like real starter resources, or a lot of your resources more in the intermediate kind of area?
So far I get complete and utter like first time ever, I don't at the moment have anything for that, or that's not quite true. I've written a book based on my training material.
Oh, you'd have? Okay.
Called Just Enough Docker Packaging, which is sort of focused on the packaging aspect, but it also starts you off with just like, I've never done this before. Run your first container, and then package your first thing, and then understand what's working. And this is a paid product. And I have a few articles that are about the basics. If you want just sort of like, first ever interaction with Docker, the Docker website has a sort of, some intro tutorials.
They're pretty good.
Yeah. And they'll get you to a certain point, but then when you hit the point of like, what is Docker packaging actually doing? Like, why, it just blew up. What do I do next? That's what they sort of, that's where you hit this wall. And I have a few articles and then a book, which are more about these sort of, you've you've done Docker run the first time, and like you kind of got a sense of why this is useful and cool, but like you need to understand how it actually works to actually move beyond that.
Yeah. I guess kind of related to that, you talk a little bit about, you have an article talking about sort of best images to kind of work with. And one of the popular ones that was out there is something called Alpine because of its size. And I feel like it some way relates to a lot of the things that we've talked about so far, in the sense that how it's prepared and not prepared for what you want to be able to do. Can you talk a little bit about that? Like what's a good best image to start with?
Yeah, and so they're saying like a Docker image is sort of a self-contained Linux file system. Basically, when you're making your own Docker image, you typically start with some pre-existing image, and then you add more files to it. It's basically a little bit like Git repository version control, where like you have the sort of initial stuff, and then you add some commit to some more stuff, and commit some more stuff, and it all gets like you're downloading this whole sort of thing with history, like it has layers, is what they call it. That can be relevant when you think about like disks, like image size, because the layers, it's like Git history. Like you don't ever, the first approximation, like things don't ever get removed, they just get added. Just like you can get history, you can go back and see old versions. And so you start with like a base image, which is like, so you don't have to like figure out how to shovel the Linux distribution to Docker image, and they provide some for you. People provide them for you. You can build in other people's work. And so you want a Linux distribution because you need at some basic level, like you need like the standard C library, and you need like a few files that Python expects. You need Python to be installed, and Python depends on like OpenSSL, so you can do like secure connections to HTTPS and like things like that. There's a bunch of libraries you need in Python and so on. The Docker has the sort of official, quote, Python Docker image, which they provide. And I tend to recommend it as a good base image for your own Docker files, Docker images. It's a good starting point to build on because it's based on Debian Linux distribution, the stable version. And so the stable version of Debian Linux sort of guarantees like security updates for packages for a number of years. But it's also stable, and so like they're not going to change things out from under you. So if you rely on some C library that you have to install, or like video encoder or whatnot, that's not going to change. It'll be the same, a sort of stable base to build on. And then what the official Docker images do, like you could just use a Debian base image, but then you're stuck with the version of Python that comes with Debian, which is currently Python 3.7.
Yeah.
3.8 is now the current version of Python. 3.9 is going to come out in like 3 months or so. And so what the official Docker images do for Python is they take a Linux distribution, by default Debian, and they install their own Python on top of it. And so you can get like Python 3.8, even though Debian itself doesn't have Python 3.8. When 3.9 comes out, we'll get 3.9. And so you get the sort of benefit of having this Linux distribution that has like thousands of packages you can install, and it's stable, and then there's security updates. But you also get the latest Python. And so it's a nice combination. It has a few gotchas, like people will often not realize that the Python install is a separate Python install. And so they'll do like apt-get install Python 3-dabs to install, think they have to install the Python 3 headers. And then they end up installing Debian's Python. Now you have two installs of Python. You have the one that Docker image provided, and the one that you just install via Debian inside the Docker image. And that's really confusing because like you do pip install in one of them, and then you can't find it in the other. And so you have to sort of understand that the Python Docker image is sort of installs Python separately from the base operating system. And so that's the one I recommend. There's a different official Python image, which is based on Alpine Linux rather than Debian Linux. And some people recommend that. And the benefit of Alpine Linux is that it's a smaller operating system. Like it was originally designed for like, embedded devices or wireless routers, things like that. So it's like quite small. And when you install packages, they install much faster than Debian or Fedora or CentOS. Like it's packages. So image builds are faster because installing an Alpine package is really fast, and the base images will be smaller. And so like if you're a Go programmer, Alpine is actually a fine distribution to use for your base image. As a Python programmer, though, it's kind of problematic. And the issue is that one of the ways they made Alpine Linux smaller is by using a different standard C library than Debian or Fedora or CentOS, any of those. Basically, if you're running a C program, and Python, for example, the Python interpreter is a C program, there's all these APIs that you need, like to allocate memory, to talk to the file system, to open network sockets, and they're all packaged into the standard C library. And so Python relies on all those APIs to write the file system and allocate memory and so on. So you need to have a C library, the standard C library available. And most Linux distributions use the GNU C library, glibc, something for short, glibc. And so when you build binary wheels for Linux, you build them for glibc, for GNU libc, because that's what the vast majority of Linux distributions work. So you do pip install pandas, you're getting pandas compiled with the assumption that it's using the glibc library. But Alpine Linux does not use the GNU libc. It has used a different one called Musl, MUSL. Maybe I'm mispronouncing it, which takes less disk and space and is somewhat compatible. So if you compile source code, majority of the time it just works, although they do have occasional incompatibilities, which I personally have hit and other people have. Because it's not quite compatible on a binary level all the time, they've disabled support for binary wheels on Alpine Linux. When you do pip install. So if you do pip install pandas and matplotlib, and you're building your Docker image using Debian-based image, like the official Python image based on Debian, it takes about 30 seconds for me. Okay, download it, it unpacks the binary wheels, and you're done. If I install it on an Alpine, it takes, I forget, it was 15 minutes? It might have been 15 minutes. Might have been 30 minutes, I forget. It takes a lot longer because you have to compile them from scratch.
Yeah.
So you have to install a compiler. You have to install all the packages with the libjpeg headers and the PNG and whatever it is that pandas and NumPy need. Then you have to compile them from scratch. And so you end up with compile times that are much, much longer. And because you have to install a compiler, you also have to do a bunch more work to make sure your image doesn't end up large, because you have to uninstall the compiler in the right way. And so if you're a Python programmer or data scientist, using Alpine Linux for your Docker images can often result in vastly longer build times.
Yeah.
And it's, one of those, people really shouldn't have to think about this.
Right. So these weird gotchas.
I don't want to spend my time thinking about what version of the standard C library is. I just want to run my software and write some software now to run. But unfortunately, these things will hit you. And so when they have these really long builds, and you won't know why. And plus, you have to figure out how to compile these packages. There's also a bunch of just how do you compile matplotlib? Well, you have to figure out which packages to install, and it's kind of a pain. And so just avoiding Alpine Linux is typically a good thing to do if you're doing Docker packaging for Python.
Yeah. I think it's super popular in lots of other languages. Like you mentioned Go. I know in JavaScript world, and what's the other one? PHP and things like that. But in general, it seems like that's definitely a good best practice initially, since we're talking about using it with a lot of these C-based libraries to help Python be a little more efficient. Then it's going to avoid all those hiccups, and that's going to be a shock, like you said, going from 30 seconds to 15 minutes of trying to install it. Yeah.
Yeah, and it's very difficult not to install packages these days that aren't binary wheels. And you might if you're just doing Flask, but then if you're doing any sort of data science or scientific computing, there's a whole bunch of compiled code, and you really don't want to compile that yourself. You really do not want to compile TensorFlow from scratch, let me tell you.
I can imagine, yeah. And then, the end of the article kind of goes into doing an overall comparison of dependencies and advantages and disadvantages of kind of both of any of the ones that we've talked about. And then the packaging type, how it's distributed, if you will. I think, it's a really good resource. I could see how it's something that you would definitely come back to and add things to as you kind of move along.
Yeah, and there's actually, in addition to Briefcase, there's a whole bunch of tools I didn't even mention. Like there's like PyInstaller, but there's also like Py2exe, which is Windows specific, and Py2app, which is macOS specific. And then there's
Yeah. Noitka is kind of an interesting one.
and there's a thing I think it's called it's not XAP PAX. There's like Facebook created some other thing which is a little bit like PEX, except but also a little bit like Docker, in that you're distributing like a compressed file system. I forget what it's called. Like it's sort of its own little category off on the side, but then you have to like install like a file system, like Squash FSFuse user space file system. It's again better for corporate doc, and there's probably other, like I'm sure there's other tools I missed. There's just a lot of use cases. I guess another tool which is in the article we didn't mention is Singularity, which is a bit like Docker, but like it came out of the high performance computing world, and so it's like designed for sort of data processing applications, and so in some ways it's nicer to use for data science or scientific computing applications than Docker is, but is also much less popular. Like you might encounter it in universities or other organizations that have like build farms.
Yeah, so those are specific machines that it'll run on?
No, you can run it like I've run on my laptop. It's more just, Docker. So Docker came out of the sort of running servers world, like from a Heroku competitor. And so it's all about the isolation. It's all like, you're going to not access the host file system because you're this little server running on your own, and you have your own network, and you're going to run as a different user.
Yeah.
Or Singularity is a lot more, you're running this application to read in data and write out data. So really you do want to access your local directory and your file system. You want to run as the current user. If what you're writing what you're packaging is saying to process some files and write them out, like using Singularity is a lot, like it's designed for that. It's just Docker is ubiquitous and Singularity is not. And so in certain communities you'll encounter it. So like SnakeMake is a sort of tool for like, processing files and then writing them out and processing them some more in a series. And I know like people in like bioinformatics and other related fields use it. And so SnakeMake has Singularity support and things like that. But like, if you're running servers, like you may never have heard of Singularity.
Yeah, it looks like you have another article on it here, and
Yeah.
sort of a Docker versus Singularity for data processing. So people want to dive a little more into it, kind of some advantages and disadvantages there.
Yeah, I should probably do a follow-up article about how packaging works, because I'm not quite sure. Like Singularity can like convert Docker images, but it also has its own packaging system, which may or may not be simpler and easier. I don't know.
Yeah. Do you have time to answer a couple weekly questions that I ask of everybody?
Yeah.
So the first one is, what is something that you're excited about in the world of Python? It could be, everything from a package to an event or an editor, something going on in the world of Python that you're excited about right now.
Sort of the silver lining of being in a global pandemic is that a lot of the conferences are now online. And so it's sort of interesting, like being able to like give a talk in a European conference. Like I might give a talk at EuroPython, I wouldn't be able to do that. It's really impressive. It was really impressive how they ran it. Like they turned it into and they expanded it hugely over if it was in person, because they're like, oh, we have all these submissions from all over the world. We're just going to add more time zones and just add more talks. Why not? Like it was amazing just watching them run it. And so it's just, I'm happy to see the ways that people have figured out ways to sort of, it's still not the same as an in-person conference. I'm still sad about missing PyCon.
Right.
It's like I've been going to for years. It's sort of I get to meet people I don't see more than once a year. But I'm very happy to see the ways in which people have managed to sort of continue these conferences and sort of continue building community, even in the face of this pandemic that means we're all to various degrees stuck at home.
What was your talk on about at EuroPython?
It was about Docker packaging, and specifically, if you are at the point where you need to get all these best practices, because it's not like you're running it locally, or you're running it like in this publicly available production environment where security matters. Like there's just a lot of best practices you want to follow, and it can be a little overwhelming if you're doing this on your job. Like chances are like after like you're always getting interrupted to do other things like, and so you don't want to like end up with a thing that's like half finished in the wrong way. And so I talked about sort of a process for, this is what you should do first, this is what you should do second. Here are some examples of best practices in each. So it's like a sort of iterative process that you start with the really critical things and then put off the less important things later on, but also like so that if you get interrupted, you sort of can leave it in a good place, not sort of half finished. You sort of like an overall process to organize the packaging because it can get pretty complicated.
Are there talks open, like that you can see them on YouTube and such?
I think I saw an announcement they were posting the raw unedited version ones. I'm not sure if that was publicly or just the people who paid for the conference, but they may be available. I think they're now doing video editing, and they'll post the edited ones. So it may well be that it's public. I haven't checked.
Okay, cool. The other one is, what are you interested in learning next? What is, again, this could be Python or maybe beyond that. What is something that you're interested in learning next?
So I have on my desk here something which I've been sort of trying to learn, but haven't quite gotten to the point of doing the exercises, which is a book called Statistical Rethinking, which is a book about Bayesian probabilistic programming. And it's written for the R programming language using the STAM library, but people have gone and ported all the code samples to other languages, including to Python. So like you can get like PyMC3. PyMC3 is like a probabilistic programming library for Python, and so like you can do all the code examples and exercises using that. Like it's like a Git repository with the whole book ported to Python.
Nice.
Although you can do it in R too. And I want to learn this. I have helped a local candidate with the municipal elections last year, and so I want to see if I can do some data analysis of like sort of all the information about who voted and like the outreach and so on. So see if I can build a statistical model, see if I can learn anything useful for the next election.
Cool. What's the title again?
Statistical Rethinking.
Okay.
Yeah, I did a little bit of research to sort of find the sort of starting from scratch book on learning Bayesian modeling, because in theory I took a statistics course one time, but I didn't ever. It was like 20 years ago, and even then I didn't quite understand it. So
yeah, David Amos is kind of like my co-host now on every other week. We kind of come in and he brings in all these articles for me from PyCoders, and that's when I found your article and learned a little more about what you're doing. He mentioned this resource on YouTube. Is it 3 blue, 1 brown, something like that?
Yeah, I've heard of that.
Yeah, and he had the one video I watched out of it because he was talking about this library that was about how he does his graphics and in Python actually for explaining these concepts. And I watched his on Bayesian theory, and it was good. It was very interesting. He's very good at distilling information and then using the graphics to kind of reinforce it, which I think is useful. So that sounds like a cool book.
Yeah, and it's aimed at scientists, and sort of you're a scientist, you're gonna have to analyze data. Like here's like how to think about this in the context of statistics. So yeah, it's about also to some extent about like the modeling process. I mean, it's been sitting on I've read it I've read half of it a couple of times just to get the concepts in, but to really learn it, I'm going to have to do the exercises, and haven't quite gotten to that yet.
And you said there's a repository with stuff in PyMC for it that kind of goes with it. Okay.
Yeah, I think possibly found it through the PyMC website, because they have here are books you can learn, and I glanced at a few of them, and this was the one that seemed like the most in terms of what I wanted.
Okay. Well, I want to thank you so much for coming on the show and sharing all your knowledge with me.
Thank you for inviting me.
I want to thank Itamar Turner-Trauring for coming on the show. And I want to thank you for listening to the Real Python Podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.